The next topic we need to talk about is a very misunderstood concept in JavaScript, and that is hoisting. So we learned that an execution context always contains three parts: a variable environment, the scope chain in the current context, and the this keyword. We already learned about the scope chain, and so now it's time to take a closer look at the variable environment, and in particular at how variables are actually created in JavaScript. So in JavaScript, we have a mechanism called hoisting, and hoisting basically makes some types of variables accessible, or let's say usable, in the code before they are actually declared in the code. Now, many people simply define hoisting by saying that variables are magically lifted or moved to the top of their scope. For example, to the top of a function. And that is actually what hoisting looks like on the surface. But behind the scenes, that's in fact not what happens. Instead, behind the scenes, the code is basically scanned for variable declarations before it is executed. So this happens during the so-called creation phase of the execution context that we talked about before. Then, for each variable that is found in the code, a new property is created in the variable environment object. And that's how hoisting really works. Now, hoisting does not work the same for all variable types. And so let's analyze the way hoisting works for function declarations, variables defined with var, variables defined with let or const, and function expressions, and also arrow functions. So function declarations are actually hoisted, and the initial value in the variable environment is set to the actual function. So in practice, what this means is that we can use function declarations before they are actually declared in the code. Again, because they are stored in the variable environment object even before the code starts executing. And I actually told you before that function declarations work this way, but now you understand why. It is because of hoisting. And just to make this table a bit more complete, so that it serves as a nice overview for you, I also show here that function declarations are block scoped, as we learned before. Just keep in mind that this is only true for strict mode. So if you're using sloppy mode, which you shouldn't, then functions are function scoped. Next, variables declared with var are also hoisted, but hoisting works in a different way here. So unlike functions, when we try to access a var variable before it's declared in the code, we don't get the declared value, but we get undefined. And this is a really weird behavior for beginners. You might expect that you simply get an error when using a variable before declaring it, or to get the actual value, but not to get undefined. Because getting undefined is just really weird, and it's not really useful either, right? And actually, this behavior is a common source of bugs in JavaScript. So this is one of the main reasons why in modern JavaScript we almost never use var. Now, on the other hand, let and const variables are not hoisted. I mean, technically they are actually hoisted, but their value is basically set to uninitialized. So there is no value to work with at all. And so in practice, it is as if hoisting was not happening at all. Instead, we say that these variables are placed in a so-called temporal dead zone, or TDZ, which makes it so that we can't access the variables between the beginning of the scope and the place where the variables are declared. So as a consequence, if we attempt to use a let or const variable before it's declared, we get an error. Also, keep in mind that let and const are block scoped, so they exist only in the block in which they were created. And all these factors together is basically the reason why let and const were first introduced into the language, and why we use them now instead of var in modern JavaScript. Okay, but now what about function expressions and arrow functions? How does hoisting work for these? Well, it depends if they were created using var or const or let. Because keep in mind that these functions are simply variables, and so they behave the exact same way as variables in regard to hoisting. This means that a function expression or arrow function created with var is hoisted to undefined, but if created with let or const, it's not usable before it's declared in the code because of the temporal dead zone. So again, just like normal variables, right? And this is actually the reason why I told you earlier that we cannot use function expressions before we write them in the code, unlike function declarations. Okay, but now before finishing, let's take a more detailed look at this mysterious temporal dead zone. So in this example code, we're gonna look at the job variable. It is a const, so it's scoped only to this if block, and it's gonna be accessible starting from the line where it's defined. Why? Well, because there is this temporal dead zone for the job variable. It's basically the region of the scope in which the variable is defined but can't be used in any way. So it is as if the variable didn't even exist. Now, if we still tried to access the variable while in the TDZ, like we actually do in the first line of this if block, then we get a reference error telling us that we can't access job before initialization. So exactly as we learned in the last slide, right? However, if we tried to access a variable that was actually never even created, like in the last line here where we want to log x, then we get a different error message saying that x is not defined at all. What this means is that job is, in fact, in the temporal dead zone where it is still initialized, but the engine knows that it will eventually be initialized because it already read the code before and set the job variable in the variable environment to uninitialized. Then, when the execution reaches the line where the variable is declared, it is removed from the temporal dead zone and it's then safe to use. So, to recap, basically each and every let and const variable get their own temporal dead zone that starts at the beginning of the scope until the line where it is defined. And the variable is only safe to use after the TDZ, so the temporal dead zone. Alright, now what is actually the need for JavaScript to have a temporal dead zone? Well, the main reason that the TDZ was introduced in ES6 is that the behavior I described before makes it way easier to avoid and catch errors. Because using a variable that is set to undefined before it's actually declared can cause serious bugs which might be hard to find. And I will show you a small example in the next lecture. So accessing variables before declaration is bad practice and should be avoided. And the best way to avoid it is by simply getting an error when we attempt to do so. And that's exactly what the temporal dead zone does. A second and smaller reason why the TDZ exists is to make const variables actually work the way they are supposed to. So as you know, we can't reassign const variables, so it would not be possible to set them to undefined first and then assign their real value later. Const should never be reassigned, and so it's only assigned when execution actually reaches the declaration. And that makes it impossible to use the variable before. Okay? Make sense? Now, if hoisting creates so many problems, why does it exist in the first place? I get this question all the time, and so let's quickly talk about that here. So, the creator of JavaScript basically implemented hoisting so that we can use function declarations before we use them, because this is essential for some programming techniques, such as mutual recursion. Some people also think that it makes code a lot more readable. Now, the fact that it also works for var declarations is because that was the only way hoisting could be implemented at the time. So the hoisting of var variables is basically just a byproduct of hoisting functions. And it probably seemed like a good idea to simply set variables to undefined, which in hindsight is not really that great. But we need to remember that JavaScript was never intended to become the huge programming language that it is today. Also, we can't remove this feature from the language now, and so we just use let and const to work around this. All right, great. And with all that being said, let's now work on some practical hoisting examples.